So this is the end of the second series of Vital EV TV here at the British Motor Museum in Gaydon, Warwickshire. And I'm standing in front of another electric car exhibit here, the Lightning GT. Now, I drove this car back in 2008 when it was a prototype through London, and I remember feeling this tremendous sense of expectation. Sadly, this never got made. It stayed a prototype, stayed a concept. But at the moment, we have so much innovation, so much money, so much hope, so much expectation coming into the electrification sector that it really is fizzing with energy. And we've got solid-state batteries, we've got sodium ion, we've got silicon on anodes. And I'm going to give you the last word, Paul, because there is so much technology out there that we can do so much with, can't we?
Absolutely, and you mentioned solid-state batteries. They are definitely going to be a thing of our future. No doubt giving us ranges possibly up to 1,000 miles potentially, which will be great for every market, but particularly the commercial vehicle sector. But truly, I need to defer to a true expert in our market, Dr. Euan McTurk. What he doesn't know is not worth knowing. So let's get over to see what he thinks. Hey everybody, and welcome to Vital EV TV here at Fully Charged Live 2023. Today I want to get under the skin of the future. It's on display all around us, but I want to know about 800 volts, battery charging, speeds of charging, all of that malarkey, and there is nobody better than Dr. Euan McTurk. Welcome, Euan, to Vital EV TV here at Fully Charged Live.
Good to be here.
Euan, tell me, this 800 volt business, so we've got a few vehicles around us right now. What is it about this change in voltage that's going to be an advantage for the future?
So when you're charging a car, power is current times voltage, and the battery voltage is going to determine how much current you need to be able to deliver a certain amount of power. So current requires a fatter cable for more amps to be able to fit through it. So if you can increase the voltage of the battery pack, then for a given power, you need thinner, lighter cables. Okay. So that saves money, it's more efficient, there's less resistive losses. So that's why we're starting to see some manufacturers switching to 800 volts for cars, and why you're also seeing it being used increasingly for heavy-duty vehicles as well. Yeah,
and does that mean we can get energy into the batteries quicker?
In theory, it's, I mean, not necessarily, but it means you can do it more efficiently. Okay. And certainly what we find with conventional chargers that we have today, the rapid or high power chargers, is that the cables will limit the actual current that can be supplied to them. So if you have a charger that says it can do 120 kilowatts, if your car is a 400 volt car, but the cable is actually maximum 200 amps on the charger, you're only going to get a maximum of 400 volts multiplied by 200 amps, which is 80 kilowatts. Whereas if you have an 800 volt car, that's not a problem. It'll be able to pull the full 120.
So it's complex, isn't it, for consumers to turn up a 400 or an 800 volt charger. How are Kempower helping in this world of multiple types of voltage and charging?
So the likes of the Kempower S series dispenser can cope with any system voltage between 200 volts up to 1,000 volts, so that's proper future-proofing that. Yeah. And that's important because we're going to see more 800 volt cars on the market. We've already got the Hyundai Ioniq 5, Ioniq 6, there's the Genesis over there, there's the Kia EV6, Porsche Taycan as well. Yeah. But we'll also see sodium ion perhaps coming into the market very soon.
As a battery?
As a battery, yeah, for kind of shorter range city cars and so on. And we may find that actually, and certainly we've seen this in China with urban new energy vehicles, the system voltage for those city cars is lower because it doesn't need to be as high, it doesn't need to have as much energy because it's only doing short runs and so on. But if you want to be able to rapid charge that, it could be that the voltage of that battery overall would be too low for some chargers, but in the case of Kempower, it goes right down to 200 volts. Yeah. So it kind of future-proofs in that sense, but up to 1,000 volts for your super-duper high-power charging, long-distance cruisers and big heavy-duty vehicles.
That's interesting. I mean, over there we've got some trucks, so I'm just wondering, it's probably worth having a walk over there to kind of have a chat about how we need to meet those needs as well.
Absolutely.
So we found some trucks from Electra, and helpfully they've displayed where the batteries are right here. Euan, tell me, the batteries that we've got here, what are they made of and why is it important, the chemistry of the batteries and also the future of the battery?
Definitely. So what we have here are lithium iron phosphate batteries from CATL, which is the biggest and one of the best manufacturers in the world. So lithium iron phosphate contains no nickel, no cobalt. They're incredibly ethical, they're incredibly safe, long lasting as well. The energy density isn't as high, so the range per charge isn't as high as NMC, nickel manganese cobalt oxide. That's your more conventional lithium cell. But because a truck has so much space in which you can mount these batteries, you've got over 200 kilowatt hours worth of capacity out of LFP using these CATL cells. So that means not only is it more ethical, it's also cheaper because you've not got the cobalt or the nickel in there, as well as being very long lasting. These will be sturdy cells, and as I say, electrochemically, they definitely get my seal of approval.
Fantastic. So these vehicles charge at a higher voltage. I think it's 650 volts. The Kempower equipment can handle that?
Easily, yeah. As I say, you've got between 200 and 1,000 volts range on the Kempower series. But if you look at some of the older legacy chargers that are maybe 500, 550 volts, you might encounter problems, particularly with trucks that are only designed for high voltage charging infrastructure. So that's where you want to double check the voltage of the entire system, and then you want to have a look at the maximum voltage that the actual charger you're going to be using with it, the rapid charger you're using with it, can take.
Now, interestingly, Euan, they tell me that you can take power out of this. So vehicle to load, they're calling it. Explain that to me.
So vehicle to load is where you're using usually the traction battery directly to provide power to an appliance. And we've seen this already in the likes of the Ioniq 5 and the EV6, where you've got a 3-pin plug underneath the rear seats, and then there's the adapter that goes into the Type 2 port. So you can have an electric picnic, as Rick Bullemere and I did in the Faster project. But yeah, in this case, we're looking at a 32 amp 3-phase output, so very much for industrial use. But that's pretty handy. You can park up and you can run some serious power tools off of that, So that's a useful extra functionality of the vehicle.
Yeah, and I guess it helps the full decarbonisation of any kind of process because you're able to use electric wherever you go, straight from the traction batteries.
Absolutely. You could rock this thing up right out in the sticks and you could have some pretty hefty appliances running where previously you'd maybe need to look at a diesel generator.
And what do you think about the future of the battery? What do you think the next chemistry, and how is that going to make a difference?
So particularly for heavy goods vehicles, heavy duty vehicles like these, it's going to be sodium ion that's going to steal the limelight. And we've already seen UK companies like Kempower, they have a chemistry, sodium ion chemistry ready to go. There's Faradion as well. And then you've got the likes of CATL and BYD who are ready to debut their sodium ion chemistries too. Why is sodium ion important? Well, lithium is incredibly abundant. People keep saying it's scarce. It's more about the supply chain and the rate at which we're extracting it just now needing to grow. There's actually enough lithium in the world for something like 19 trillion Nissan Leafs. So we're not going to run out. But sodium is even more abundant.
Oh, wow.
So that means also because it's got a very mature supply chain, it's cheaper to extract, it's cheaper to make. The materials in sodium ion are far more abundant, cheaper, etc. And not only will that bring the cost down, but also they are safer and therefore cheaper to ship. Because sodium ion can be completely discharged to 0 volts. You can't do that with lithium ion. If you take them too low, you damage the cell irreversibly. But you could put a resistor right across the sodium ion battery, ship it halfway around the world, and then charge it up again. And that means you don't need to worry about special shipping regulations or anything. It makes it so much cheaper. So you've got the saving on the materials, the saving on the shipping, and that's going to be significant cost reduction for anyone using it, whether it's going to be in shorter range vehicles or actually decent range heavy duty vehicles.
So this is really good news for the future, isn't it? Because the biggest objection that many people are giving is, of course, price. And we know that the cost of these trucks is double or even sometimes 3 times their diesel counterparts. Not specifically these electric vehicles here, but just generally in the marketplace, that's the noise that we hear. So that sounds like it's good news from an ethical point of view, it's good news from a supply chain point of view, but it's also good news from a price point of view.
Definitely.
Fantastic. CCS, CHAdeMO, which is right and which is going to win? This has been a bit of a debate for some time. So, Euan, what's going to win?
So CCS is basically the VHS that's won the format war. I've had a soft spot for CHAdeMO because it was really well defined from the off and it was capable of doing vehicle to grid. So you can power your depot using the vehicle and you have a revenue stream that way. It means that, if you've got a reliably positioned vehicle that's there at certain times of the day, you might not need to buy a separate battery storage system to bring your cost down. So it's a 2-in-1, you're sweating the asset. But CCS, there are now vehicle-to-grid trials underway for this at long last.
Fantastic,
So
yeah.
we should start to see that coming through in the not too distant future. And in terms of the charging speeds that it supports, you're looking at 350 kilowatts,
Yeah.
which in fact the Kempower S series goes up to 400 kilowatts
Yeah.
off, if I remember correctly.
Yeah, it does.
So for your return to base heavy duty vehicles, that's plenty to charge the vehicle in well under an hour. Yes, there will be the likes of MCS coming out. That's your kind of megawatt charger for super
big
long haul
trucks.
logistics.
Yeah, yeah.
But these are big trucks,
Yeah.
and they are doing, you know, sizable mileage every day. But it's somewhat more predictable,
Back
and
to
it's back to base.
Yeah.
AC might not be quick enough to charge it
Yeah.
overnight before its next shift,
Yeah.
but CCS definitely is. So that is definitely going to be here for the long haul.
Perfect. So when you're behind the wheel of a truck, you just want to be able to get the job done. And the last thing anybody needs is a vehicle that doesn't charge and then you can't get the job done. How does Vital EV with the Kempower solution help on this front?
So Kempower's hardware is generally amongst the most reliable out there on the market. Kempower have been very impressive in looking for any kind of issues with a very kind of niche make and model of vehicle. And as soon as they pick that up remotely, they then work on a fix for that and push that update to all of their chargers right across the globe without actually physically touching them. So by the time you turn up in an identical make and model of vehicle to a Kempower charger, the problem's already been fixed. The same cannot be said of some of the competition, and I know this from painful experience of some fleets. But also, Kempower uses OCPP 2.0, so the Open Charge Point Protocol. 1.6 has been around for ages and it's good, but 2.0 has some clever extra tricks up its sleeve, and Kempower uses those to good effect. For example, if the charger detects that one of the power modules is getting a bit hot, that means it might be about to fail.
Yeah.
So it reports that remotely, not just to Kempower, but to Vital.
Yeah.
So because Vital has a 4-hour service lead time agreement, that means they'll have a technician on site probably before the unit's even failed.
Right.
It's a preemptive thing.
Yeah.
So it basically knows when to schedule in an appointment with the technician to make sure that everything's okay. That's exactly what you need as a fleet to minimise downtime and to make sure that as soon as there's a hint of something going wrong,
Yeah.
Vital is on the case.
I mean, uptime is absolutely king, and it sounds like Vital are really well positioned to be able to maximise every tool in the bag.
Oh yeah, again, I've been speaking to loads of fleet managers here at Fully Charged Live today, and some of them have been quite rightly ranting about very poor aftermarket service from some of the competition. I won't name names, but it can be pretty bad. If you go cheap, you end up paying twice. And in fairness, the cost of the Kempower kit is actually a bargain in comparison to what's out there, and you're getting that 4-hour SLA from Vital. And I've heard directly from fleet managers here today who have Kempower hardware through Vital that not only is the hardware quality great, but the aftermarket support has been brilliant too. I've only heard good things.
Well, that is fantastic news. And this has been a fantastic roundup of the future. I hope that you've enjoyed it as much as I have and learned as much as I have. So, until next time, have a great day.
So thank you for watching. This is the world of EV, electrification, energy transition, and from where I'm standing, it really, really is exciting. And we need to electrify all those vans, all those trucks, all those buses, all those coaches, and we need to work on air quality. And don't see this as a real kind of threat to the status quo. This is good. This makes the world a better, cleaner, greener place with cheaper energy for all. And that's why it's worth doing.